Hey everybody, this is Larry. This is me doing virtual contest, weekly contest 465 Leetcode. Hit the like button to subscribe and join me on Discord. Let me know what you think about this contest, these problems, and everything in between. This is a live recording. So definitely, if you look for explanations, check out their own videos. But yeah, let me know if it's worth keep on doing these, because I feel like people just don't watch these, and I don't know why I'm doing it at some point, to be honest. I'm just looking at my notebook and pencil, just making sure that I have it ready. And since I am, we can get started. Yeah, hope everyone's okay. Long weekend, I think, right? So for those of you, enjoy the long weekend. But for me, let's go, right? Go. Okay. Am I recording? Okay, just want to make sure. Sometimes I just forget. Wait, am I looking at the right thing? Okay, yes. All right, you're given an integer array or length n, friends. Order is 1 to n, some permutation. Friends, your friends sort of idea of just in a strict. Okay, and the finishing order. Okay, so it's just a mapping, right? For I, x, something like that. Finishing order of my friend, so my I friend is 1. Why is that not? Oh, IDs. Okay, so in this case, we just care about 3, 1, and 4. Okay, so actually, I mean, you could do it that way, but okay. So you sort by their index. I mean, there's only 8 friends, so I think we don't even have to, but we can do something like right, and then friends dot sort keys equal lambda x, lookup of x, and then that's it. We're doing probably using one more line. Oh, whoops! How did I forget? Okay, where is it? 314 532. Would be really bad if I messed that one up, but all right. N and k, split the number n and the k positive product of these things. Okay, I mean this. Oh, k positive. Oh, up to 5 numbers. I think that's the small part. There's no like part 2 of this, right? And it could be 1 for some reason. What is the difference again? The max and the min? How do I want to write this? I mean, I think it's just straightforward, but brute force, right? Is it brute force? Is it brute force? Yeah, okay, maybe it is. It could be only, so square root of that, well, derises, I guess 1, 2, and plus. Something like this, right? Like big ends, that's why I don't know, it looks so confusing for me. But yeah. Something like this, right? And then it's just about. I hope this is fast enough, honestly. Well, yeah, current is fine, right? Like a little bug flying around. Then Oh, we have to keep track of the thing, not just the answer. Okay. Difference is okay. Then we want delta is current delta is equal to that, and then you see delta is more than 3. Oh yeah. What is it again? Any order, any one spread. Okay, so it doesn't even matter. Otherwise, then it's just from maybe that I need to use D. Make it B. Oh, I'm being dumb. Okay. Just the current array. And then current number. Maybe right. Good job, just keep track of index as well. I mean, it's not meant to be memorization, so I don't think we have to be that smooth about it. So then now we go. A little bit awkward. I feel like I'm making this harder than it is. Trying to do like random optimizations in my head when I don't need to. Yeah, I mean, I think we can. Maybe I don't need this. Maybe it's fine. How am I? Do a square root every time, can you? No, that's too slow, I think. Even just 2 of them is too weird. Yeah. Maybe I'm just underthinking it. These are all the devices. And then the number changes after the first one. I mean, that's the part that I'm. Am I dumb? I mean, the other way to do it is like binary search. Maybe. I don't know if that's true. No, I mean, kind of, but you have to be very careful. No, I don't. Maybe it's not even. I don't know. Why am I struggling on this one? They're not that many devices, Larry. Just go. I mean, maybe there are, but let's just go anyway. And then we'll worry about everything else later. Yeah, whatever. No. Something like this. Oh, yeah. Actually, I want something like this plus 1. Is it too slow? Maybe because there's a while loop and I don't. Outputting no is not great. Means this never happens. One. Delta is greater than this, then delta. Oh, that is sloppy. How is that never? How does that not give you an error? Alright, I mean that's also not right. But oh, I didn't check. But this is like way, I don't know, I'm not happy about it. Let's actually test at least one big number. That is actually remarkably fast. The power of 2. 32, I forget what. 2 to, not 20, 15, 18, 17, 16, 6, I don't know why I told me that. 655, 325 or something. Or 3, let me just copy and paste it. Today my brain is not functioning on math. Is it 5 to better? I don't know. Alright, YOLO submit. If it times out, it is what it is. It is pending though. Okay. Maybe I overthought it. Maybe I worried too much. The analysis isn't so good though for me. Like I didn't do a good analysis on it is what I mean. Alright, let's focus. We have, how much time do we have left? We've only used up about 10 minutes, 13 minutes. A little bit slow for sure, but we can make it up. Alright, nums ij such that I times j, or nums of I times, and the binary of them does not share any bits. And it's big. Okay, so n is big. dp. What's 10 to the 6 again? 10 to the 6 is a million, so 20. So each one. No, each one doing a million is too slow. What are you doing? I feel like I should know this one, but. I mean, set intersection is fine, but no. No, not intersection. You said union, right? That doesn't make sense, though. So for each one, we want let's say we process left to right, right? 1, okay, fine. 2, okay, no intersection. That's fine. 3 has intersection of everything, no good. 4, no intersection anyway. I mean, it could be DP. It's just 20 times 20 million is a little bit slow though. Basically, yeah. I mean, maybe. No, I keep on thinking of ways of just like removing them as a query, but no, I mean, we have to do queries a little bit better, right? Alright, let's think about it one bit at a time. Where would that go? So 1 would have to see 0. Does this work at one bit at a time? No, because it doesn't do the maximization of it. Okay, and then now you have 2, 2, 2. I do like the reverse of it or something. Okay, so let's say we want to look up the reverse. Yes, I mean that's the thing that I was saying about kind of DP, but not really. For each number, can you figure out everything in before? Can we even pre-process this in a good way? Or process this number? If it has 20 bit, if it has 20 bits, then that's a lot of numbers. I mean, you can't do it for every number. I mean, it feels try, but I don't know how to do it. Is it just greedy on a try? Am I just being bad today? I guess so. For each number, if it is a 0, then what? Then you look for 1s. If none exist, yeah. Why am I struggling today? It's just a try greedy problem, right? For each number? Okay, fine. Wow, this is such an obvious try problem that I feel so bad about. I have to worry about, you want to worry about optimization? Maybe not yet, it's fine. Right. This is technically a node. So yeah, I don't know why I struggle with this one. This is actually pretty straightforward. Yeah, I mean, okay. So then now we just do it by 20, right? So maybe you just start with right, and then now current node is equal to root, and then now if current to x is greater than 0, then we want to go through the path of 1, right? Okay, so now if this is a 0, we want to go for 1 if it exists. So if not, go to 0. If neither of them exist, then we're just done, right? Okay, fine. Yeah, okay. Yeah. Very rusty today. Okay, so if cnode.edges, so if this is a 1, we want a 0. 0 is not none, then cnode is equal to c.edges of 0. Else, if cnode, okay, else if it's a 0, and then now else, then we just not found, we break. Right. Otherwise we have a 0. So then now we want to, well, in a greedy way, we want to see if 1 is available first. I could probably write this in a for loop, but I always feel like this is a little bit better. Okay, so then now, yeah, so we went through everything, meaning if current is equal to 0, then we have found it. Well, I guess the found doesn't do anything actually. Then now cnode is the thing. Okay, this doesn't do anything. We wanted 1, so then current and found is the thing, and then now it's just x times found. Best is equal to max as this, and we are good, and that's it, right? I should have known this one like quicker. I'm just off shape. Unless I'm returning 0 in all of them. Yeah, well. Oh, I didn't insert stuff because I'm a silly boy. Okay. Okay, so that's found, and then now we do it again, but this time, this is a pretty straightforward try, but I wrote this in a really weird way. we have like an implicit thing on the edges. Yeah, I write C notes. System and edge implies the existence of a number. Oh, that edges. So how did that know? Oh, I don't shift. That's actually funny. But yeah, I don't shift. This as well. Ooh, not right at all. Why? Okay, so X found 1. 3 found 1. Is that even true? That's not even right. One of this is not true. Because if this is a 1 and this is a 1, we don't actually go here. We actually break. Because we have a 1, it doesn't even matter. Actually, yeah. Okay. Actually, this is an else. If it's 0, then it's fine. Yeah. Okay. Better, but not quite good enough. 2, 1, 3 doesn't match anything. It's good. 4 doesn't match anything. That's good. But max is not a 1 though, right? Max would be the 3. So it should be. So 0, 0, 0, it tries to find 1, doesn't find it, it's fine, finds a 0. But then now when it gets to thing, did I create this wrong or something? Why am I so bad at it today? Because 4 should find a 3. This is a pretty standard problem. Why am I struggling? Okay, so if it's not none else, then this is defined. Is that right? Okay, if it's 0, if you find a 1, go find a 1. If it doesn't, find a 0. Otherwise, neither of these exist, so we break. It doesn't matter, we do. Okay, fine. Right. Yeah, what the hey? I not the creation maybe is tricky though. 1 to the 20. If do we change x? No. If this is a 1, if this is a none, then we set it. Otherwise, oh, this is for the 1. I don't like doing this as much as you like seeing it. I still have to. I have 1 hour and I still have to do Q4. Okay. Something. I don't know. This is the 1. This is the 2. So this is seems to be right. 3. Why is this not finding? Is this weird? This is definitely. Oh well, it's not creating because it exists. So then it's just 4, 0, 0. But why is it not finding though? So creation actually is right. Okay. So it's a 4, so it tries to go to 0. That's true though, right? Am I off by 1 somewhere? It's so annoying to debug too. Here's the way that I wrote it. This is 1. Fine. Zero, zero, zero. Three found a 0. That's right, actually. And current is a 1. Should current be a 1? Yeah, because as a 1 as a bit, so it skips the. Okay. Yeah, maybe that's right. Yeah, okay, fine. The 4, why? Because as a 4 has a 1, so it goes to 0 on a try. But then now after that it has a 0, right? So then it should try to find a 1. Why? Why are you not trying to find a 1? Why are you so lazy? 4. The way I write this, trying just to micro optimize a little bit, it's dumb. Why though? Am I missing something? Man, why am I so bad? It's so straightforward. If it's not none, then you go. If it's not none, then you go. Current is 0 for this, right? Current is 0, but found is 1. You should try to find the 3. Why is this not a... Did I not create it correctly? Am I off by 1 in any way? Current. Shift by 1, shift by 1. Oh, I'm dumb. I don't know what there's too many points. How did I miss this? Larry! Usually I use a helper function, that's why today I'm just being a little bit lazy and dumb. Alright. Alright, there's still a print statement though, that's what I'm trying to find. So dumb. Ooh. Actually, don't expect the wrong answer on this one, actually. So that feels pretty bad. Okay. Did I miss something? Because I thought that would be it. C node is equal to root. So we created, okay, file, okay. Okay. So what's the answer here? 0, why? 15 is all ones. 9 and this is 9 and no 9 times 2, so that's just this shifted, right? What is a 9 again? Okay. I have to print some. I don't even know what they are. Well, I don't want to print. Okay. Why is it 162? Oh wait, no, this one and this one. So 9 and 18. Okay. I mean, that's fine. Why am I wrong? Am I doing something else that's stupid? So we break current. We reset current, reset nodes for the... This is so dumb. I'm so dumb, I mean. How? What am I doing? This is such a basic problem. I'm now not happy about this at all. Okay, 9. I mean, yeah. It just doesn't find anything, right? Is my greedy wrong? It tries to do... Maybe my greedy is wrong, actually. because it tries to go down the 15 path or something, or the 15 path, but the 15 does intersect where the 9 doesn't. Right? Let's try to figure out whether. I see. Maybe my greedy's wrong. Then what? Okay. Then maybe I'm just being dumb in general. I mean, it is possible to go down the wrong path. Even though I don't know that. I don't know why this is though. Right? Because this still should go to both of these. It goes to the 1. Oh yeah, no. This does go to wrong path because then it goes to this 1, but then it's no bueno. So how do I? So it's not a try problem, huh? Even though it took me a long time to debug that anyway. How many people got Q4? I don't. Can I get Q4? Do I have enough time? Huh? Why am I so bad? Wow. Is it just DP? 20 million seems a little bit much though. Maybe it is. Okay, let's try it, and I'll just convert the language if I have to. I thought, okay. I mean, the DP I got right away, but I thought that was a little bit too slow. But we'll see. Okay, so then now, how do I write this? So it is something like for x in nums, dp of x is equal to x or something, right? And what does that mean? Because you want the opposite of everything. So you want the biggest number that, yeah, okay. I mean, I think that's fine, but, and then now it's just for, honestly, I don't think this is fast enough, but, right. What is the get next split thing? I forget how to do it. Okay, so yeah, it's something like dp sub I is equal to f max of dp sub I, and then all the previous one, right? So j, right? And then it's just for b is equal to I, while b is greater than 0, then the leftmost bit, or the rightmost, it doesn't really matter, but it's just you go to b to or something like this. Or the other way. Is it this or negative? I always forget. No, that doesn't make sense anyway. So, okay. Gives me the rightmost bit. So then now, this one want to flip I by this bit. No, this is J. Right? And we also want to flip it on B. I think that's fine. Or I guess this is also this way of doing it. And then now, yeah, right. Let's run it real quick. But this is so slow. Yeah, I mean, this takes 5 seconds and we have 3 numbers. I mean, because it always takes like 20 million. So I don't know that this is going to be cut it. I mean, why don't I know this? All right, we have 48 minutes left. Let's skip to Q4. Maybe I'll come back to it. I don't know. I thought try was a good way of doing it, but maybe that doesn't make sense. Because the greedy isn't true. Okay, well, we have 7 pointers, so that's even tougher. All right, so maybe today is going to be a rough day. I mean, there's a lot of cheaters on top, so I don't know what that means. But okay, some of beautiful giving into away nums of length n. There goes my hopes of going to bed early of my beauty sleep. All right, for every positive integer g, we define beauty of g as the product of g and a number of strictly subsequent of nums. What of? All right, mod, I guess. All right. What does this mean? You define beauty of G. Return the sum of beauties. Okay, so that means that we have 1 of order strictly increasing subsequences. N is actually only 10 to the 4 for some reason, but okay. Sum is interesting. Was that 70,000? Are you trying to bait me into a SIF? How many sequences of? Okay, let's say we go left to right. Well, it has to be increasing, strictly increasing. So the order kind of matters, but okay, so let's say you have 3. What does that mean? So there's some like weird DP thing, maybe, I don't know. But look at it. Okay, let's say, I mean, it's 10 to the 4, so you can do n squared DP, but let's say you do a very basic DP, right? What would that look like? Well, 3 and 2, no bueno. Just add 1. Okay, so then all the previous numbers we processed, how many of them gives you a 1, how many gives you a 2, dot, dot, dot. So then it's just the number of divisors of so you do want to do a SIF. But then it's not just that though, right? Because there's the increasing portion. So if it's just any subsequence, maybe it's easy. Well, I think it's easier in any other case, but it has to be smaller number. What does the smaller number mean? The strictly increasing means that the GCD cannot get bigger, right? Okay. If it's strictly increasing, then the GCD cannot get bigger. So then for each one, what does that mean? the biggest GCD for that number is going to be that number, and then for example there's also 1, right? So there's one sequence of 1, one sequence of 2. And it's only of numbers that are smaller, right? And you could walk the number that are smaller, can you? Walking the Sith. Remember, it has to be smaller, but yeah, I mean, something like this is kind of interesting. Okay, so then each number is, of course, itself a thing, and then it's 2 times 3. Right. There's no way this is easier than Q3. I still don't know how to do Q3 either. I think I'm gonna come back to it. Is there any real people? I don't need this animation, you silly boy. You got in 3 minutes, so okay, let's go back to farm 3 real quick. I mean, Uri is very good, of course, but what am I missing? I want to I mean, if we're using the tri-way, we want to be able to. That's actually kind of nice. If we want to go down path only if we know that everything inside that path is good, right? How do I write that in a good way? Everything before is good, but everything after, right? Has to at least a 0 has to exist, maybe? No. How do I do in each node can I do this backwards? Can I look at numbers and then no, that doesn't make sense. Maybe I should have done this in the morning and not now. About 40 minutes. I'm not even close on 2 problems, not only 1. Is there like some sort of DP on the bits? No, because it's any index, right? We could sort it. Does sorting give us anything? I mean, not more than what my try should have done, but it's just wrong on this one, right? Because this is wrong because of the binary bits. Because it forces you to go down. Yeah, I mean, okay. Oh man. Maybe this is why people don't do contests at 4 a.m. I don't know. If it's not try, I don't know. Maybe that's the version. I have to reset. I don't know. It's not try, maybe. Am I just missing something? Draw it out. No, this one you had the visualization. All my ideas with tries don't make it better than n square in the worst case. I don't even know how to handle this case. DP is definitely too slow because it's almost fixed. Q4 is interesting. I want to solve Q4, but I don't even know how to do this one. Maximum. I don't. Bits are so weird. There's no. I'm trying to think like of higher power ideas. Oops. I still don't get it though. I mean, how is this going to even work fast enough? Maybe this is too crazy. I don't know. Basically, you want? I mean, I might as well finish writing it. At least something to YOLO. Something like do something like that. It's not quite that though. Because you want it for the 20, right? So it's actually. And then it's actually something like that. Right? Does that at least give me the right answer? I mean, it does, but it takes 6 seconds. I'm gonna YOLO submit because just to kind of have it on the thing. But like, there's no way this is fast enough. But am I missing something? Yeah, I mean, I'm not 15. How many things? Yeah, at least this one was close, but it's not doing. I don't know how. Maybe this is too complicated. I don't know. I mean, can't really optimize that much. This is still. This is two. This is 1 million. I don't know. I mean, maybe you could do some optimization on this thing. I don't know, like I don't know. But at this point, it's just like guessing on the input, right? I mean, this is faster, but it really so much depend on the input that like it's not like I don't think that's yeah. I mean, I guess I YOLO submitted the other one, so I might as well record deal with this one too. But there's no way that's gonna pass, assuming the inputs are actually reasonable. But I don't know. This is like a nutty one. I don't imagine her. What? I was gonna convert it to Java just to see if I could, but this is stupid. Is that intended? Well, I'm just lucky. Right. This is long. Let me just. Telling ChatGPT to give me long code to convert from before. Alright. This is I mean, we had this idea for a long time. I just didn't think that it would be fast enough and with reasonable. Alright, well, at least we have time to play around with this one. I honestly, it's just a guessing game. This is ridiculous. I just kind of have nothing else to try. Okay, but at least we get to play with Q4, so that's always good. I don't know. I mean, the ideas, I think, you know, like, there are ideas, but for something like 4 and 6, right? 4, you have one number that's a 2. Is that enough for the 6 to pick it up on? No, I don't think so. I'm allergic to something. I don't know what's going on, but I'm gonna drink more protein. I've been losing too much weight. How do I deal with the increasing part? We could pre-process them in order. No, does that even make sense? So the biggest number is by itself, and then as it goes to the left, it can only go smaller. We don't have any idea on Q4, but I'm annoyed at Q3. Honestly. I mean, there is definitely a SIF in here. Let's see what would that look like, or whatever. I don't know why it is such an odd number. 1, 2, 3, 4. Right. Something like this, right? Okay, just part of the GCD. Like a small into larger type thing. How do I look up a small? Like for example, you have 4 and 6, and then you do this. But what if you have 6 and a 4 even? How would you even handle that? Because the 4 you may type the 6. How is the strict increasing part? I mean, strictly increasing part. I don't even know how to handle the strict increasing part, even though I have a magic function to do the thing that I think I could do, but maybe not. Excuse me. Is there a thing on the level? No, the count doesn't matter, but for every one, then you just have a even if you have a dictionary on each one, we can't even afford to just look at the thing, look at each number. Right? And then also, let's say, yeah, how do you skip work? Like, what if you have 466? And you can't even dedupe them because you could have 4646 or something. And then now what do you do? Hmm. 20 minutes. Yeah. I don't even really have ideas. It's just maybe beyond my scope for today. What is the dividers? That's the thing, right? Like, for example, we have 4 and a 6. How do you figure? Okay, so let's say you just look at every divisor. So again, 70,000 because for most divisors, it's going to be 128 divisors. So actually, that's not bad. Why did I think this is going to be so bad? Is there an easy way to get all the divisors? I forget. Other than square root method. Okay, but let's say we have all the divisors. 128. Can I do it? Um, 70,000. What is square root of 70,000? 264. 264 should be okay. Actually, why am I spending so much time on this? Maybe I'm just conditioned to use SIF, but actually, okay. So, okay, what happens if we have the divisors? Then for each number, we could do dedupe, that's fine. But I don't know if that helps that much, but how do you even get all the smaller numbers? Your binary search on each one? That seems a little bit crazy. Can though, right? So you sort by the thing and then just keep track of the indexes. Binary search on each divisor. Even on each divisor is crazy, but okay. Is it just math? And for each divisor, which is a possible GCD, we count number of things that appear before us. But is that enough? Because we have to extend it out. Number of subsequent, it's not just the previous element. I don't know. Well, okay, so let's say you do check every divisor. What can you do? You check whether they exist. Because for 6, I guess in theory, you check for 2, and then there's a. I guess you could binary search on that too, but if you're going to binary search anyway, then you could just binary search on the number of numbers that are smaller than here. But then okay, so a number. But how do you count the number of things that with this divisor is the GCD? How many things? There's the increasing part, which is already tough. And how do you even know that? I don't know. Like, why 4 and 6 is 2, but what if you have 12 and 6? Why would you not say that is 2 or 3 and pick 6 directly? Inclusion, exclusion? I mean, I don't know, 128 devices is still a lot. I don't know this. Can you do number of primes? I guess number of primes is a lot less. Can you do inclusion, exclusion? Actually. Right, I guess I could Google that. Was it 70,000? What number has the most prime factors? Six primes? But that's 6 unique primes, right? 16 is the one, but 2 to the 16 for every number for inclusion, exclusion is probably too much. So 16 is too much. Okay. I mean, who knows with Q3 apparently working. So I don't know, but now I don't even know how to get the increasing part. Let alone, you know, all these other stuff. Why do I stay up till 5 a.m. doing this? All right, let's try what I said. I mean, about 10 minutes. I'm not gonna finish on time, but at least we can show some homework. Okay, so then now, okay, fine, right? So, I'm trying to figure out whether to mix it, whatever, same thing. Did I write this before? don't have the same. I don't. Things are getting blurry. Did I already write this? I don't know. Okay, so then now we have this, right? And then we have. Maybe if. Oh. Okay. And then now, how do we want to write the other part? There are two ways to do it. One is by looking at the index. We could sort X by the thing. Maybe that's a little bit better, and then we look at the index. Either that, for each divisor, we store the biggest number, or just store the actual original number, and then just keep track of what is small. We have an actual count. I don't know though. Let me do it this way for now, maybe. And what we want is also I got everything lookup. It's kind of actually I guess I could just do this. Okay, so then now we want to say for D in X, lookup div of X. So for each number we want to just say P of D dot append X, right? Maybe something like that. Okay. Well, I mean that's for processing, so I guess we have to do a little bit before, which is for D and X. We want to get count of. There is some. I still don't know how to do it though. Well, like I don't know how to get the formula, right? In the sense that okay, so then now we have P of D. Should it be a sorted list? I mean, yes, but I'm trying to think. That just adds an extra log. I guess it's not that bad, but it is actually. I mean, it's not that bad per se, but I think there's a lot of overhead. I mean, it's not. Right, and then now we can do a left of X. So all the numbers that are smaller is equal to count. But what does that even mean? I mean, okay, but I don't know, I have no time. Can I do something like this? That's not quite right though, is it? I'm just YOLOing, like trying random stuff. I don't think this is right in either case. It may even be too slow. Especially when, no, I didn't have an infinite loop. Do I? I mean, I must, right? Because otherwise this should not time out. Is anything obvious? Do remember the increment. Alright, well, can't do anything right today. This is the only loop, but why would it not get big? Is it this part? Oh, this part I forgot, and I don't use it. Alright, let's just get rid of those for now. Alright, good. I mean, I don't think this is right, but I'm trying to suss out, like, does it even feel right? What do you think this is? P of D. Oh, whoops. Is either one or the other, but I didn't need to either. Okay, I mean, this is definitely very wrong. Also, I'm forgetting one. Yeah, okay. I don't even know what that means. So basically, I have 1 minute. I mean, this doesn't make any sense. I don't know what I'm doing, but it's just YOLO hope, but this doesn't even make sense really. Okay, so this is the count, which is true, but I don't know how to take advantage of it. There's some like dynamic programming maybe, because then now, okay, what am I actually storing? There's some maybe? No, that doesn't. I mean, the count is the number of elements that are before it. Alright. Okay, so for each number, what does that mean? For each element, and these are all numbers that are smaller, so let's say the 5 of them, but it's not, because it has to be increasing, right? So you can only pick so it has to be unique, but I mean, we just went off to oh no, I forgot to take a picture. I guess I'll take it from my screenshots, but still, I hate how Leetcode does that. I just take it from my movie, but my video. Okay, but okay, let's think. Count is fine. Is it? How do you get the number of increasing things from just here, right? So it's already sorted. So let's say you have 5 numbers of the same divisor. How are you going to figure out how many contributions there are? And also like the ordering of that matters a little bit. Well, I don't think I understand this one at all, to be honest. I mean, I think I this part is fine-ish. It's either this or the sieve. I don't know. Though I somehow messed up the sieve anyway. But this part I'm thinking it more along the lines of DP, but I'm not really getting it. Unless there's some like crazy algo that I'm not aware of. Well, then I'm definitely not getting it, but it doesn't help me with this. And then the other alternative is to sort these and then and if you sort these, then you get it on the indexes. What does that tell me? Does that tell me anything different? I don't know. Honestly, I don't even have a great general idea. It's not even like I don't know, but I could grind it out. Like yesterday's problem where I just couldn't get the formula, or earlier today or whatever. Okay, so this has 1, 2. What does that 1, 2 mean? And 1, 1, because 1 is always a divisor. That doesn't even help. Maybe there's some inclusion exclusion thing. Man, I'm not practicing enough for these problems anymore. And which would be fine, honestly. I would still do these if even for the cheaters, because it's just I should still be the same relative level, even if not solving these per se. I'm trying to also think whether I could do it the primes way, but I think that's like path dependent, which is a little bit awkward. Maybe. How do you get GCD from primes? Right? If you don't take the same path, like if one has 2 2s and 1 3, and then one has 1 2 and 2 3s, it's hard to kind of find the 6 together. But this way is not working either. Like, okay, so 3, fine. How do you even I don't even know how to set it up. I mean, okay, let's say we have go the other way of just giving track of the indexes. Does that even work? I mean, you still get to count the same way. I just don't know what to do with the count. Like, well, the count is also not the GCD. I mean, or D is not the GCD. It's just the divisor, which can be in a number of things, which is why I don't know how to do it. Like maybe there's a thing in which keep track of D in a good way or something. Is that in? It is the thing with the inclusion exclusion, I guess. Well, but in a DP kind of way, right? So maybe. So then now, yeah. So for example, if we have 6, then it's 6 minus 2 and 3, recursively minus the 1s, something like that. I could see it. I see. Okay, I think I get it, but that's kind of annoying to do, isn't it? So basically for 6, what do you want to do? For 6, you want to subtract out. Okay, so you want to add out the number of 6 minus the number of 2 minus the number of 3 plus. I mean, in theory, but honestly not quite sure if I would do that correctly. But almost like inclusion exclusion type thing, but in a DP-ish kind of way. But no, is that though? I see. So then for each divisor, and assuming this is sorted, if this is sorted, actually that's pretty bad. I just forgot. Oh no, P and D is different. Okay, I was gonna say I forgot to sort it. Okay, if we sort, what does that mean? That means that we'll be going from a small number to a bigger number. The multiple paths. I don't know enough about. I think the idea is probably maybe right, but with the DP, but I don't know how to do it. This is why you study. Right, I'm gonna cap this for another 15 minutes. And then I'm gonna maybe pick this up again the next day or something. I'm really annoyed that I don't. I would say the good thing is that the extra time that I spent on Q3 didn't end up mattering, in the sense that I would not have gotten it anyway. But so I guess that part is good. I wouldn't have gotten this one anyway. I just don't know the math for it. I mean, we handled the strictly increasing part, but I think there is some, like, it's not this, it is that. Like, has to be something like, I don't know, right? And it's not just adding, maybe. It's whatchamacallit. I mean, you have to do, it's multiplying for some way. And you have to divide it under mod, so you do the modular inverse thing. I don't know. I'm gonna stop doing these at 5 a.m. Alright, next week I'm gonna get enough sleep. I was hoping that, yeah. I forgot what I was doing. So for each one of these, and these are all sorted. And now Don't you have to figure out the branching? I don't know. Maybe not. Maybe I should add itself. I guess the way that I did it doesn't matter. It should be count plus 1 maybe, but if you want to handle it that way for itself. Yeah, I'm not making any progress. I'm gonna call it a night. Can't even show that screen. That's what I have. Yeah. I was gonna call it a little bit longer, but I think there's a knowledge gap. To be honest, which it is what it is. I think I made good progress, but I just don't. Number theory stuff that maybe I'm a little bit shaky on. I guess I could also just review. Where's Alex? Didn't someone say Alex was there? TS Reaper is fine. Yeah, we'll take a quick look to see if it's something that I can even do. I don't know why they don't make these bigger. Like, why? What are you doing with the entire, like, more than half the screen? In any case, Alright, that's interesting. I mean, this is like the factor thing. I mean, it's not factorial, but yeah, it's like the divisor of each number or something. It's kind of what I did, except for primes. Okay. I can read this just because, like, I don't know why they make it so, like, they spend all the money in the world just to make it impossible to read. Like in a way that normal people would read code, which is on a big screen. All right. Precision of. Oh, okay. So I mean, we did this. They did it by indexes. You could search on either one, I suppose. Okay. I mean, I had both ideas in my head. I didn't know which one. I mean, I didn't know either one. So, all right. We have the mod. We have this calculator function. I don't know what it does. What's calling this? So mx is the max number, I assume. Okay, so mx is the max number. So then we just f sub I is equal to calc sub I. What does that mean? Oh. Okay, so every number we do a calc sub I. We create for x in position of k. What? I mean, x is an index here, right? So for every index that has this divisor k, yeah, okay. So for each, okay. I mean, this was kind of the idea I was thinking of, but I couldn't figure it out. Oh, I see. I mean, I don't even know the rest of this, but I think this this is kind of the idea that I was trying to think about, but I couldn't get it. But this was the DP that I was talking about with the inclusion. I called it inclusion exclusion, in the sense that you get all the smaller ones, so that I thought that you could do it multiple times though. So this is for every divisor. No? Okay, so for every I. Okay, so for every I, this is for every multiple of things. Oh, I was thinking of the other way actually. I don't even know all this stuff, so I'm probably still not right. So there's a whatchamacallit tree. Binary index tree. I suspect that's just used to count the number of smaller numbers or something. Actually, we could just read it, right? Oh yeah, this is, wait, do we use MP? Is MP the tree? MP is not the tree though. We push back. Okay, so for every number, oh no, for every, okay, so I mean, I was looking for this. I had it flipped the other way in my head, which is why I couldn't figure it out. But I think the way this doesn't make sense, because I just couldn't figure out how to branch out and get all the divisors. Actually, I just did the math on the divisors, to be honest, because I thought maybe I have to be a little bit stricter than this. Because even going up, I think I could have gotten it. But I think going down makes more sense in terms of that inclusion exclusion thing that I was thinking of. But okay, so you have a binary index tree here for every okay, so this is for every index, so we go, okay, so this is all the numbers that, oh okay, because they're merging from the back down, which I did not do. Okay, right, so then now p dot second is, what's m? M is kind of an incrementer, but how does that change MP? Well, this is P. Well, this is MP. That's, oh, this is a very weird. People write things in such a weird way, but yeah. Okay, so that means that we sort the numbers. Oh, so it's just like, so this allows you to get the longest increasing subsequence thing, and then I guess this allows you to get, I don't know, what does this allow you to do? I mean, this is the binary index tree. Oh, I guess this is just to get the number of sequences. Yeah, okay, this is just to get the number of sequences that has, I guess, this k as the answer. Yeah, and then you want to subtract out the 5. Okay, I mean, I'm trying to think whether I want to, like, quote unquote upsolve this. Like, do I actually, like, I what I try to do in these things, by looking at other people's code, is not to copy the code, but to get enough of an idea so that I can implement it myself, right? I think the biggest thing I did not realize to do is that I was thinking recursively, but actually you only have 128 devices, but each of those 128 devices only have 128 devices. So it's actually not that bad if you're able to aggregate them in a good way. But I did not. I also kind of, so that's a thing. I don't know what this is. Oh, I guess this is, yeah. Because then now you do like a D square thing. 128 square maybe is a little bit big. 10,000 times 10,000, maybe a little bit on the bigger side. That's like 100 million, but a lot of them are not possible. So maybe that makes it a little bit better. But yeah, because you subtract out the bigger numbers in the count. But yeah, and that's how they get the prime shift is how they did the divisor thing. I did the divisor this way, but this prime shift or the factor shift makes sense as well. All right, let's see if I can upsolve it, quote unquote, upsolve from my thing. I mean, I had a lot of the ideas. There's nothing that I don't know, so I guess that's good. But I think I wasn't able to kind of deconstruct the problem in a useful way. And here, what did I store? I saw the numbers, and I do them in order instead. I don't know that that's better or worse. Okay, so maybe I have this, right? And then maybe I have basically the idea here. Maybe I shouldn't try to make. I know that I'm trying to get my initial idea and try to make it work. Maybe that's not a great idea, to be frank. I also don't want to. Like, I feel like there are similar ideas that I can do that I'm exploring that are not exactly just another carbon copy of their code. And now I close the window. I try to not look at it until like I'm really confused again. But and we divisor, we want to say like, okay, I mean, I don't know why I wrote it this way. Maybe just write right, so then now f of d, so this is sorted, yeah, so then now it's equal to count, and then maybe we just do d, my previous d, but dp is too confusing. In div of d, but then we have to calculate this d. Yes, that's right. I mean, I think this will work, but it is too slow, which is fine. But okay, let's. I mean, I know that I'm doing it a funky way because I don't know enough to optimize it before knowing it. I mean, I guess knowing the answer, but we could get all the devices for the max number. Okay, so nums, right? And so then now we have for x in range of max plus 1. And it's just this part. I mean, I know that I could do it the Sif way, but for now, we'll just pretend that I didn't know the Sif way, right? I guess it's just this because we only can do it once anyway. And we go to side of 1. Right, okay. This is probably a little bit messy, but maybe I don't need to do all the number. Maybe I could do like a memorization thing, but let's not optimize anymore. Let's just see if we can get it at least correct, and then we can think about optimizations. Okay, and then now where we previous d f of pd minus f of d, right? So that we get, then those are not unique anymore, so we don't do this. And then now, okay, so this is the part that I mean, the reason why I didn't think about this is because during the contest, or even just earlier, I thought this would time out. So I was trying to optimize it, but maybe for now, I just want to do it this way. Yeah. I need to add 1 to this. This is the previous. I want to add 1 to this for the current number that we don't add. Okay. I mean, even if we add it, it doesn't show up anyway, so it doesn't matter because it's the bisect left. So then now, yeah, for key value and f dot items, then now the key is the GCD, right? And then it's just this. I mean, I know that I'm too lazy to mod it, but I don't know why this. Oh, my output is ridiculous. I was looking at this, I was like, huh, that seems lucky. I don't think that's right, but how does this even work? I don't know. All right, so let's say print x. Oops. Print x. Oh, because I have too many negative numbers, and then it just gets modded. I see. Because all of the divisors, all the previous numbers should have or also have been, right? Because it's just like a not recursive. No, I mean, okay. I mean, I guess we'll print it out, but that shouldn't happen that we have negative things. That's the part that I don't get, maybe. Also, we shouldn't have 0. So 1, this returns 0. This for each. Tell me it's a little off, or maybe a lot off. Should be 1. All right, let's read. Oh, because it has itself as the divisor. Because I'm a silly boy. Yeah, I mean, it shouldn't have itself. I was just trying to think whether it should. But because we start at 1, then, you know, we have these things. We just do 1. Okay. I mean, at least it is slightly better, but is it? Well, now it's subtracting it from 1. So that's, oh, it's because it was because of the number 1, and then it subtracts it from, okay, fine. So, 1 is a special case, maybe. So for all the devices, because it adds 1 and then it subtracts it from itself, right? Well, okay. I guess we can write it this way. Start at 2 because this is silly, and then diff of 1 is just 0 to. Okay, is this better? I don't know, but we'll see. One should have 1. Alright. This is very awkward actually. Because 1 is such a weird number. And I don't know if I should special case it because it's very awkward, but okay, fine. If okay, so if D is not equal to 1, I don't know. It's just very weird to do it. Okay. Now this is still wrong, just because. Okay, we fixed the 1. The 2 should, okay. It should have itself in here, I guess. It should have itself, but not here. I guess that's the thing. Okay, maybe that makes it okay, and we just go back to 1. Maybe. Okay. It's kind of what I was hoping, so that's good. Not quite right though, but it's a start. Because it doesn't do the numbers quite right. And this still has negative numbers, which means it is very well. But okay. I mean, I feel like we made okay progress. Okay, so yeah, 2 goes for 2, and then subtract. Yeah, maybe the reason is because this way doesn't. We have to do all the numbers together, I suppose. Yeah, I mean, I see why people didn't do it this way. I mean, part of the learning and exploring is kind of figure this out. But the reason why people don't is because then now this doesn't make sense actually. It doesn't do the previous number, so you have to do the numbers together. Okay, fine. Right, then how do I rewrite it? I mean, that part's not so bad. We should have a help before this. Also, I need to use the bathroom. Right, and now it's almost like DP, really. You get the contribution of each thing. we process these one by one. Maybe. What are we doing? Is that what I want to do? I'm gonna process the numbers in order. Yeah, I don't know. Like yeah. Honestly, I remember too much of the other solution that I can do it, but I don't want to do it that way. But I don't know how to express this though. Otherwise, I guess maybe it's just the idea. Alright, fine. Let's see if I can go to bed. If I figure it out. Okay, so then maybe you have something like, right, and then now we're saying that not only this, but for every factor divisor, right? Yeah, I mean, I guess you could do a sieve that way too. Just that for like. Something like this, right? Let's do it here. Right. I'm not ready to get this up yet. Okay, seems fast enough. So we have 1 or 2 numbers. Still fast enough. Okay, fine. Maybe I should think about using this more in the future. Okay, so then now x in thumbs. Then now for every diff of x, we want to say we want this number to be calculated for, as a possible thing, and then we just, I guess the subtraction is the only problem that I had issue with really. I for index. Yeah, okay. Right. Okay, right. And then now we're trying to count the number of subsequences where the GCD is this number. Yeah, I'm going to write G, but I guess that's not quite G over G lookup, maybe that's a little bit better. For G in range from 1 to max. How many subsequences are there with G, right? So G with all the indexes, right? Yeah, and this will be already be in order. So now what? So with all these indexes where they do have this thing, maybe I don't understand this part. I mean, this part was the part that I actually did struggle with the DP part. Number of subsequences where GCD is G. We have these indexes in order, right? We want to sort them by their value. Okay, no, that makes sense. So, okay, so, yeah. We want to sort them by their value, which is nums of it. Okay. So then now these indexes are sorted. Print it out real quick. Oh, I have spaces. Okay, so now 1, you have 1, 2. That's right. Should have a 0 actually. I don't know how to handle the 1 case. It's a little bit weird. They should all have ones, right? One case is always very weird, actually. I don't know if this is right, to be frank. Like the number 1 and GCD1, but I'll just try to focus on getting something right. For example, every number should be in here. So we have 0 and 1, I guess that's fine. But oh no, this is because I have this. I forgot that I put an extra case. That's why that's a little bit awkward. Okay, fine. All right. Okay, maybe that's fine for now. We'll see. Okay, so G, right? So okay. But this isn't quite right in the sense that okay, maybe that makes it a little bit right. Yeah. Okay. Oh, okay, so then now we don't need the 1 anymore. Okay. Right. So then now this is just the number of numbers as we now go from indexes from left to right. This is the numbers of numbers that are smaller than it, because that's just how you do the thing, right? Okay. Yeah, that makes sense, because that is then now because you're summing up over. Yeah, that's why there's a binary index tree. I mean, I don't know if it's necessary, but I guess that makes sense. I mean, we'll do it that way. Let me find my binary index tree. And of course, my site is always down when I need it. Okay, fine. I have to reset it, but for now, we'll just do something stupid and ask ChatGPT. Thinking longer for a better answer. No, just give me a clean code. Why? What? Why is this so? What the? Give me a basic. I have. The annoying thing is I do have code, but my server is down for some reason. Well, there's some reason it's because people are always DOSing it. Okay, but okay, we'll see if this is good enough. And this is from ChatGPT, I'm not gonna lie. We don't need some range. Some prefix is good enough, right? Yeah. So then now we want to say, okay. Binary index tree, I guess so. And what is n? Well, with G, that's too big, right? What's 70,000? No, 70,000 times 70,000 is too big. Length of indexes? Okay, yeah. Yeah, because then now... Yeah. What am I doing? Yeah, that's right. Okay. So then now we have for I in indexes, maybe just index in indexes. We want to go, I mean, this is basic TP, right? So from left to right, we go how many from the previous index. So then that's just 3 dot some prefix of the index or index minus 1. Oh no, something like this, right? I guess it doesn't matter because index is not taken yet, so. So it should be the same. Right, so this is count is equal to this. And then is that good enough? Right. Okay, and then now we can say, yeah, for the factor of g is equal to total. I think this is maybe right. This should be right. Count is the number of thing, and then the dp of index is going to be sum of all those other previous things. Okay, I think that's right. And then the tricky thing is trying to get back to it, right? So which is, yeah, for same as before, really. For d in f dot keys. Oh, I guess I have an I here. I'm just looking at this code, basically writing the same thing but in a different way, slightly different way. The if, because then now we want f this is actually reversed. We want this reversed because then now you can go f of I and then now this is the unique thing. So then total we added by, oh, this is another total though. Total. Just go t total. Then now we have f of j or f of I times I, and then just mod things, right? Something like that. Okay, what did I do? Well, some prefix. That's weird, right? I guess index can be 0. So maybe that just makes things weird. Okay, fine. Still makes things weird. Why is it going about? Oh, because this is the length of the indexes, but we're doing this on here. So we actually need to normalize these. Okay, that makes sense. That's annoying, but it makes sense. Yeah, okay, yeah. Yeah, function for this, really. Do I want to, how do I write this again? Man, what am I? Oh, we're normalizing it. Sorry, it's 6:15 a.m. and I have not slept yet, so I'm slowing down a bit. But this should be a easy part of it. But I am, yeah. So, but because there's a lot of index and indexes and I, so I'm just like confusing myself a little bit. But so what I want. Oh yeah, okay. So then now when we sort, did I do it the wrong way? So when we sort, I am so confused. I think we can just do it this way. Let's just say we sort it, and now my computer's lagging for some reason. Why? Am I running out of hard drive space again? No, okay. Because my computer's just doing crazy things. Okay, so then now index is equal to I. Okay, so then now indexes is equal to lookup of index for index in indexes. Okay. Oh, oops. I don't know why my computer's lagging. I'm not running anything other than this recording thing. I don't think. Okay. I mean, rough a go. We could print F real quick. My eyes are already closed. Okay, so we have 3 ones. It's not quite what I want to hear. I don't know why these are zeros. Maybe this should be count +1 for itself. Actually, okay. I don't know if this is good, but it looks more promising. I don't think there's 6 ones though. 1 2 and 1 3, and also somehow that only sums up to 9. Oh, that's because it's pre-processed. So the 1 dupes on the 2 and the 3, but does it count itself? Handling the 1 is always so weird for me. But this seems okay, so that's actually, I don't know if that's true or not, but okay, we could get the final version. I mean, the final version's a little bit more interesting, maybe. No. No, we have to do it this way. Okay, so you have 4 ones, but I don't know how it is missing the 1 6, 1 4, and 1 2. Maybe that's fine. But I don't know how it's missing the, well, which one is it missing? Dun, dun, dun. Okay, so for G1 is equal to 1, because this is, no, I mean, you could print it, right? Yeah, 0 1 2. So for 1, this would give us 6. 6 is 6, right? You have 0 plus 1 plus 2 plus 3, right? That sounds right. So, oh, why is 3 2? 3 being 2 may be wrong. Huh. Was that 2 before? Oh, no, that's not 2. That's index 2. Whoops. Okay. I'm looking at the wrong thing. Okay, I mean, okay. So 6 is right, 1 is right, 1 is right. But then now for 1 we want to remove the one for 2 and one for 3. Do you? What am I doing wrong? Okay, so we loop the 3, delete everything. I mean, loop the 2, nothing of course. Loop the 1. We have 6 sequences. Is that true? Even on dupes? Okay, 1, 2, 3 has. Why am I getting 6? Well, what does 6 mean? And what does the 4 mean? It's actually awkward. I don't know if it's a property of the ones or something, but because the 1 subtracting out the 2 and the 3 makes sense, but the 6 so maybe my DP is wrong. Do we add 1? Or do we add count plus 1? Because it doesn't make sense, maybe? No, okay, well. Oh wait, maybe this is still count plus 1 though. Because then now. Yeah, I don't know why I put 1. Okay. Because that's the number of sequence that we add the current number to, plus 1 being itself, right? Oops. This is a very hard problem. I mean, I think, well, I guess we'll find out whether this is right or not in like now, so it doesn't matter what I think. But honestly, I probably just like copy 80% of it. But I forgot about this part being fast enough though. So that's a little bit annoying. And of course getting the wrong answer is also annoying, but that's okay. We got halfway done. What am I misunderstanding? Okay. Let's see this thing first. Oh, maybe there's something to do with the unique numbers. I don't know that I handle it well. But I don't know if the overcounting is good or bad, actually. I don't know if I handled dupe numbers correctly. No, because it overcounts here on the number of subsequences. Okay, that's an easy fix if true. Because then we have to do this. Because we sort by the number if it's deterministic, but or if it's what you might call it, not deterministic. What's the thing where it keeps the same order? Man, today I am stable. If it's stable, then it keeps the I. But even if it's not stable, that means that there's a random chance it's not. So we have to make sure that we actually want to tie break by negative I, so that doesn't do it. Okay. Okay. I mean, that's actually. I mean, for me, that's a good sign, to be frank. I mean, not only because I was able to fix it, but that means that I actually understand it enough to fix it, right? Because if I didn't, then we're probably just copying and pasting code. If it times out, maybe I'm okay with that. In the sense that 9 seconds. In the sense that it's not wrong. We have to do some optimizations, but it looks like we're okay, able to do without. I cannot keep my eyes open, so I'm gonna call it a night. Let's do a quick retro. I forgot to do it bi-weekly, but Q1 was straightforward, honestly, right? I mean, you know, Q2, I don't have my timing up. I mean, I could get it from my video, so I'll do it later. But yeah, I mean, Q2 was fine. I think I ended up doing 10 minutes. Actually, now I remember a little bit. I thought maybe it's a little trickier, and I forgot about it. I was like, I remember doing something like this, but yeah, that's where we belong. Q3, I mean, Q3 was the one that's crap, if you ask me. Because there's no way this should be fast enough. I mean, because it's way input dependent, right? If you put one number that's 10 to the 6, like if I just do, okay, so for example, if you run this, it gives you no time, right? But if you just even give one number, it doesn't have to be, yeah, that intense. Two sizes, okay, fine, right? Like, I thought that would actually be slower, to be honest. Why did my last thing so slow then if I did it the other way? Huh. Did I mess up? Oh, this is my Java code. Oh, that's why it's so fast, because it's in Java. I thought it would be slower, to be honest. Oh, because I don't have all that bit. So what we need is not just M, but not just a big number, but was it 65536 or whatever it is, right? Actually, still not that bad. I don't know. Oh, it's 1 million, not 10 to the 5th. So I have to do a few more. What's 2 to the 19? Okay, right. It's not 2 to the 19, it's 2 to the 19 minus 1. So then you have all the bits. I don't know why I had to calculate -1. That is the kind of day I'm having. But yeah, as you can see though, if you have just 10 cases of that, it'll be timing out, right? So, I don't know. Leetcode is very weird. And Q4 is fine, but yeah. Anyway, yeah, I mean, I don't have the leaderboard thing, but I mean, I didn't do self Q4, so until afterwards. I gotta remember the divisor thing, because the Civ thing I always forget. Still, I mean, I'm getting better at it, but I still always forget the complexity. That's why I didn't really attack it this way. And then the divisor thing is just like the opposite of this, right? Like we could have probably looked it up actually. Like get a reverse lookup. I guess this is the reverse lookup though, so it's fine. Well, I mean, you could check that we actually use it, but maybe it's fine because we actually use all the numbers anyway, the way that we wrote it. I don't know. That's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye bye.